you have a quiz on Friday. It will include these and all 3 of the exponent rules. We'll probably go over 2 of the exponent rules today. That way tomorrow can be a review day because you're going to need a review on the exponents, trust me. So we know we've got GEMDAS, right? We have grouping symbols. Grouping symbols again are parentheses, brackets, square roots, and absolute values. Do I have grouping symbols?
Yes.
Yes. So I do what's inside of the grouping symbols. 2 plus 1 is 3. And I'm going to rewrite the problem. In here, I have grouping symbols. 8 plus 2 is 10 squared. Notice how it already has gotten smaller. Okay? Is there any other things? Well, Mr. H, there's still grouping symbols. Yes, there are. Is there anything to do inside of the grouping symbol? No. So grouping symbols is done. Then we have exponents. Are there exponents?
Yes.
Yes. That's what happens next. So 10 squared is 100. I can leave that in parentheses if I want. Okay. Now, before we get here, I'm going to read. 9 divided by 3 times 3 minus 7 times 100. Multiply and divide are both step 3 because we go from left to right. Does it say that multiplies first?
No.
Does it say divides first?
No.
No, it says read it and do it from left to right. 9 divided by 3. That's my first step. So that is 3. Then this comes down. Minus 7 times 100. Everybody still with me there? Then read 3 multiplied by 3 is 9 minus 7 times 100. I've seen a lot of you try to do 9 minus 7. No. So now we're still multiplying 9 minus 7 times 100. So that's 9 minus, that's 700. Okay, I see a lot of erasing, a lot of different writing. Now we're to add and subtract left to right. 9 minus 700 is negative 691. And notice how it will always look like a funnel cloud or a upside down pyramid, something like that. What questions do you have?
None other than I got it.
Are we good? Is that making a little bit of sense? Okay. Homework out, let's go over that. We had 1 through 10 on that worksheet. I told you do not worry about negative exponents yet. Number 1. Okay, have the worksheet out. Are we ready? I don't want to go too fast. Are we good with this? May I move on? I'm sorry. Okay. Okay, are you still looking for it again? There it is. Okay, here we go. You ready? Number 1 should be 4m to the 5th. Number 2 should be 2m, or if you put 2m to the 1st, that's fine as well, because we know that a variable that does not have an exponent always will have an exponent of 1. Number 3 should be 8r to the negative 1. Number 4 should be 8n or 8n to the 1st. It's fine if you have it to the 1st. That's not going to get it marked wrong. Number 5 is 8k to the 5th. Okay, number 6. We're going to do number 6. We're going to come back to number 6 in a second. Number 7, 6y squared x, or if you have 6xy squared. I like to put things in alphabetical order. Okay, but either is fine. So if you have 6y squared x, that's completely fine. Or 6xy squared is completely fine. Number 8, 4 v to the 4th, u to the 2nd. Or 4 u to the 2nd, v to the 4th. Number 9, I should have 12 a to the negative 1st, b to the negative 1st. And number 10, x to the 5th, y to the negative 2nd. Are there questions besides number 6 right now? I would love to do any of these. If you're like, I missed this, can you show me? Okay, so let's take a number 6. I'll look at number 6. Erase this real quick. May I erase? We all have this copy down. We're good? Okay. Hey, listen, I know that I teach a little bit different than a lot of teachers, so if you're like, hey, Mr. H, I need you to slow down. I need you to leave something up. Please do not hesitate to let me know, and then I'll just tell you no. It's a joke. It was a joke. I was joking.
What did I do?
What haven't you done, Mariana?
Bro. I'm getting hated.
Hey, don't pick on Mariana.
Why am I disliked?
Okay, here we go. Number 6. So we have 2x to the 3rd, y to the negative 3rd, times 2x to the negative 1st, y to the positive 3rd. Okay. So first and foremost, it is a multiplication problem.
Yeah.
We know that 2 times 2 is 4. We have like bases with our x's. We keep the base. 3 plus a negative 1 is 2. Then we have a y and a y. We keep the base. Negative 3 plus 3 is 0. If you have this, I'll mark it wrong. Anything to the 0 power. So when we have a number next to a variable, what mathematical operation does it mean? What does it mean when we have a number next to a variable? Do you remember? It's multiplication. So this is really 4 times x squared times anything to the 0 power is
0.
1.
That's what I meant to say. Yeah.
So really this is 4 times 1, which is 4 x to the 2nd. So if you got 4x squared y to the 0, that's not wrong. You're doing the right steps. But anything to the 0 power. 27 to the 0 power is 1. X to the 0 power is 1. A fish to the 0 power is 1.
Yep.
0 to the 0 power is not. That's something different, but we're never going to have that. Okay? So if you have a variable to the 0 power, it is 1. Okay? So right now we have two different rules. If I have xy, that really means x to the 1st, y to the 1st. If we have x to the 0, y to the 3rd, that means 1 times y to the 3rd, which is just y to the 3rd. Okay? Those are two of the rules. Yesterday, there's 3 big rules that we're doing for exponents. And I want to make sure that you copy them down every day. So, let's start some notes. Here we are, exponent rules day 2. I would have these, right? Like, I put them on the board. I don't put things on the board just for me. I know the math. I would make sure that I put them in my notes. So we're getting ready to do some notes, which means you guys need to have your notebooks out.
Yeah. Share that now.
Okay. So our first rule for exponents was the product property, which I said was multiplying like bases. Okay, and an example was x to the 4th, y to the 3rd, times x to the 9th, y to the 7th. And we said we keep the base, we do 4 plus 9, we keep the base, we do 3 plus 7. That gives me x to the 13th, y to the 10th. Okay, that's the property. Okay, have I lost anybody there? Let's talk about our two new properties today. Like bases in different levels. Okay? Like bases in different levels. Quotient. What does quotient mean? What mathematical operation? Products multiplication.
That means division.
Quotient is division. So here will be our first example. X to the fifth divided by x to the third. Okay, let's write this out in expanded form. Ready? So that's going to be x times x times x times x times x. That's what x to the fifth means. Does everybody agree? Yes? Okay. X to the third means x times x times x. Have I lost anybody yet? Okay. What is 7 divided, or yeah, get your calculators. What's 7 divided by 7? If you don't need a calculator, that's great. 1. What is a bazillion divided by a bazillion?
1.
What is negative 5 divided by negative 5? 1. Variables take the place of an unknown value. So they're taking the place of a number. So if I have the same number divided by the same number, what does that become? 1. So x divided by x is 1. X divided by x is 1. X divided by x is 1. That leaves me, how many x's here?
2.
An x times an x, which leaves me an x squared, really divided by 1, because that's what's left over in the bottom. But anything divided by 1 is the anything. How do we get there? Because there's got to be a better way. Let's try another one. I'm trying to get you guys to figure it out. Here we go. Let's go x to the third, x to the fourth. So I want you to notice something. Before we do this one in expanded form, where was my bigger exponent? The top level, right? And those x's stayed in the top level. Before we expand, where's my bigger exponent? On the bottom. You guys said bottom. So then we have x multiplied by x multiplied by x, x multiplied by x multiplied by x multiplied by x. Okay? It's a division problem. Do you agree?
Yeah.
Yeah, that's what the quotient property means. X divided by x is 1. X divided by x is 1. X divided by x is 1. What's left over in the numerator? 1. Because all of those are 1. What's left over in the denominator?
X.
We can leave it as x or x to the first power. Okay, Mr. H. There's got to be an easier way than doing this. Does anybody see something that's happening right now?
You subtract.
We're what?
You subtract.
We are subtracting what?
The numbers.
We're subtracting the exponents.
That.
But it matters where the bigger one is. In this case, the bigger one was in the denominator. So we keep the answer in the denominator. 4 minus 3 is?
1.
5 minus 3 is 2. So it's going to matter. So if I do something like this, they have to be like bases in different levels. X to the 5th, y to the 12th, x to the 3rd, y to the 16th. Okay. So where are my like bases? I have x's and I have y's, right? Let's start with the x's. Where's the bigger x, top or bottom? Top, so that's where the x is going to go. I do 5 minus 3 is 2. Okay, those are done. Where's the bigger y? Which we call the denominator. And then we do 16 minus 12, which is? 4. How are we doing so far? Okay, pretty easy? Okay. One more thing. We've got the power property. The power property an expression all raised to a power. Okay? This one's my least favorite. It's a little bit trickier. So let's go like this. I've got x to the third raised to the fourth. So this is a power to a power. When you do this, it's like a distributive property. Distributive means multiplication. We take the number on the outside of the parenthesis, which is a power, and we multiply it to the power on the inside. Because this is saying x to the third 4 times. So really it's saying x to the third times x to the third times x to the third times x to the third. 3, 6, 9, 12. Or 3 times 4 is x to the 12th. Because that's this grouping 4 times. Does that make sense? But Mr. H, what if we've got something like this? And this is where it gets a little bit trickier. 4x y to the 5th z to the negative 2. All to the second. Okay. So we didn't do this yesterday. First step. What's missing? What's missing?
X doesn't have one.
X doesn't have a 1, but neither does the 4. When we have a power raised to a power, everything needs to have an exponent. Everything does. Because we are taking this power and we are multiplying it to every exponent. So we keep the bases. So 4, 2 times 1 is 2. X, 2 times 1 is 2. Y, 5 times 2 is 10. Negative 2 times 2 is negative 4. And we'll talk about what to do with that tomorrow. Okay? Am I done?
No.
Why not? I gotta do what? You're saying words and you're not talking about them. He's like, do this, huh?
My brain's not working.
What else do I have to simplify? The 4 squared. 4 squared means 4 multiplied by 4, which is 16. X squared. Y to the 10th. Z to the negative 4th. And again, your homework says don't do anything with negative exponents. That's not the right answer. No, this is fine for right now. Okay? Can we do another example like that? Would that be all right?
Sure.
One more, and then we'll get to homework. Okay, so now we're putting some of these steps together. I will give you 2 minutes. See if you can come up with a solution to this one. So you are simplifying. Kind of, but not quite. So there are two properties at work here. There is the power property, and then there is going to be the product property. We need to do parentheses first. So everything needs an exponent, including the 5. So if you didn't do that, you already done screwed up. Okay? We take the 2. We multiply it to the 1. We take the 2. We multiply it to the 4. We take the 2. We multiply it to the negative 1. So now I have 5 squared, x to the 8th, y to the negative 2. I don't need parentheses anymore. And then I have x squared, y to the 3rd. Okay? Now, I can do the product property, which is multiplying like bases. So first, I have to simplify my numbers. 5 squared is 25. Still good there. Then I have an x and an x. I keep the base. 2 plus 8 is 10. I have a y, I have a y. I keep the base. 3 plus 2 is 1. I can leave it like that, or I can put it as y to the 1st. Either one is correct. How do we feel?
I feel like I did absolutely wrong.
Homework. You are going to do 11 through 25 today. Actually, no, I lied. Let's do 11 through 24. Okay, so on the same worksheet, you were doing 11 through 24. This will be due tomorrow. We still have a quiz on Friday. Tomorrow, we're going to talk about those negatives.
How do you do this?
We're going to go from there. Are we good? Love y'all. Get started.
Okay.